Let's look at a proof for the addition and subtraction rule for derivatives. So the addition rule states that you can add the functions and take the derivative or add the derivatives. Likewise, you could either subtract the functions to find your values first and take the derivative, or you could subtract the derivatives. And we're going to prove this using the limit definition. I'm using the letter K here because we've already tapped into F and G. So the derivative of the function K is the limit as h goes to 0 of our function k of x plus h minus k of x all over h. So this k of x plus h minus k of x, this is like y2 minus y1. If you were to subtract the insides, x plus h minus x, you would get that h there. So this is very much like a rise over run situation. We're looking at slope. Let's go ahead and prove the addition formula here, and we'll see that the subtraction formula is just a modification of this. So I'm looking for the derivative of the function f plus g of x. And you can write that as f plus g of, in parentheses like this, or you could write it as f of x plus g of x. Either of those notations work just fine. So this is going to be the limit as h goes to 0 of our function. Our function here is f plus g at an x value of x plus h. Subtract our function at x. So k of x plus h, our function of x plus h, k of x, our function of x. And this is going to be all over h. That's how far apart x plus h and x are. They're h units apart. Rise over run. I'm going to write this top expression a little bit differently. And I'm going to put some parentheses up just to be really careful with the signs. So I've got f of x plus h, because I really have f of that input. And I also have g of x plus h. So that first expression piece that we had earlier with f plus g, this is another way to write it. And this is f of x plus g of x. This is all over h. Now I'm going to combine some like terms here. And like in the sense that I'm trying to group together similar functions. So for example, I have this f of x plus h minus this f of x. So I could write that as f of x plus h minus f of x. Likewise, I can link together this g of x plus h, and then a minus, I'm thinking of distributing that negative, minus g of x. So I've taken these terms and I've rearranged them so that way we have f and g together. Now, when I say this whole thing is divided by h, that means each of these four terms is divided by h. So I could write this as another way, as the limit as h goes to 0 of f of x plus h minus f of x. I need to divide all of that by h, and I need to divide both of those g functions by h as well. I'm taking the limit of this whole thing, so I can think of that as the limit of the first function, subtract f of x over h, and the limit for the second different quotient piece for the function g. f of x plus h minus f of x over h, g of x plus h minus g of x over h. This looks like this difference quotient formula for the derivative. Here I have the derivative for f, and here I have the derivative of g. So we can either add our functions inside of the limits, or we can take the derivatives of each of those individual functions and add to those quantities together. Now, I mentioned that the subtraction formula follows from this. Let's see what would change if I switched this plus sign to a minus sign. So that plus sign would make this a minus sign here and a minus sign here. So I would have minus g of x plus h and minus g of x. In this step here, I'm noticing that both the g of x plus h and the g of x are getting hit by a negative. So I actually have right here subtraction of that quantity. So I'm going to flip that center sign because I have a minus in between the f and the g. And I would get the same thing here for the subtraction rule, following exactly the same steps, just changing that sign in the center. So that was a formal proof for the addition formula and an outline of what that proof looks like for the subtraction formula. Let's look at more of these equations together and see where they come from and how to use them.